Assalamu alaikum students. Today we are going to discuss implicit differentiation. So before we start that implicit differentiation, it's important for us to know the difference between explicit and implicit functions. I have written two examples here. Example number one is it states that 2y minus 3x square plus 8 equals to 0, and you can clearly see that I can make y the subjects clearly. Y equals to, we can write it as y equals 3x square plus 8 divided by 2, right? Easily I can make this y as expression of x. Okay? We can make y the subject. While on other side, so this is an example of explicit function, right? On other hand, this is 3x square minus 6xy plus y cube. We cannot write x or y as subject, or we cannot write y in terms of x or y in terms of x. So in this situation, this is known as implicit functions, where we cannot separate x or y. So implicit function is like this. Okay, now after this, one more thing, we will be differentiating implicit functions, and there are basic two things you need to remember. So derivative of, we know that derivative of x is 1, but derivative of y is dy by dx. Now this is something you need to remember. Dy dx of x is 1, derivative of x with respect to x is 1, but derivative of y with respect will remain dy by dx. Its example is, for example, I am differentiating derivative of x cube. So this is going to be 3x square power minus 1 into derivative of base, that remains 1. But if I am asked to find out derivative of y cube, this remains 3y square into derivative of base, that will be dy by dx. So whenever we have derivative of y cube, it would be, we will apply power rule, it is 3y square into dy by dx, right? Dy by dx will come along. So derivative of y cube will be 3y square into dy by dx. So let's start implicit differentiation. You will be having questions like this. So yes, for example, this is a question. It states that the equation of the curve is 3x square minus 4xy plus y square is equal to 45. Find the gradient of the curve at point 2 minus 3. So this is 3x square minus 4xy plus y square, right, is equal to 45. So what we are going to do is we're going to differentiate it. So that will be 6x minus 4, and we apply product rule here. First function as it is, derivative of second, plus second as it is, derivative of first, plus y square will be 2y dy by dx. Because y पे जब power rule लगेगा, it's going to be 2y square, 2y dy by dx is equal to derivative of 45 is 0. Now let's simplify. 6x minus 4x dy by dx minus 4y plus 2y dy by dx, right, is equal to 0. Now at this point we are going to rearrange it, because we are looking for dy by dx only. So we can write 2y minus 4x into dy by dx, and you can take 4y and 6x on other sides. So that will be plus 4y minus 6x, and in next step you can write dy by dx is equal to, it's 4y minus 6x divided by 2y minus 4x, right? This is your dy by dx. Okay, this is your dy by dx. dy by dx is 4y minus 6x divided by 2y minus 4x. Okay, now basically find the gradient at the point given was 2 and minus 3. We are going to substitute 2 and minus 3 here. So dy by dx is going to be 4y minus 6x divided by 2y minus 4x, which is equal to, it's minus 12 divided by minus 6 minus 8. So that is equal to minus 24 divided by minus 24 divided by minus 14. So that is equal to 12 divided by 7. So dy by dx for this point is going to be 12 divided by 7. Okay. In part B, show that there are no points on the curve for which gradient is 1. So for such cases, what we do is we just substitute this gradient equals to 1. So in part B, it is 4y minus 6x divided by 2y minus 4x is equal to 1. Cross multiply here, that is going to be 4y minus 6x is equal to 1 into 2y minus 4x, right? And now we will simplify it, that is 4y minus 2y is equal to 6x minus 4x. So that makes it 2y is equal to 2x, that makes it y is equal to x. Now what we do is we go back to the original equation and we substitute y equals to x in that. Okay, so original equation is 3x square minus 4xy plus y square is equal to 45. Now we need to substitute this value in it. So you substitute y equals to x. So 3x square minus 4x x plus x square is equal to 45. 3x square plus 1x square, 4x square minus 4x square is equal to 45. That makes it 0 is equal to 45. So 0 is not equal to 45. This shows that, you would say this shows that there is no point on the curve. There is no point on curve for which dy by dx is equal to, for which dy by dx is equal to 1. So this is a complete question that states the equation of the curve is 3x square minus 4xy plus y square is equal to 45. Find the gradient of the curve at the given point. So we use implicit differentiation and we simplify functions in this manner to find dy by dx, right? And once we have dy by dx, then in part B they want us to show that there is no point on the curve at which the gradient is 1. So we put gradient is equal to 1, and this is the situation we got, y equals to x. So y equals to x, original equation is 3x square minus 4xy plus y square equals to 45. We substitute the original equation y equals to x in the original equation. That gives us 0 is equal to 45. So that means this is not the true situation and there is no point on the curve for which derivative is equal to 1, right? Okay, let's move to next question now. Find the, for each of the following, find the gradient at the point where the curve crosses y-axis. Okay, now y-intercept we have x0. So for part B, 2x cube plus 5xy plus y cube is equal to 8, right? And for y-intercept we have to put x0, right? So in this equation, if you put x0, we are left with 0 plus y cube is equal to 8. That makes it y is equal to 2. So point is 0 and 2, right? Now we need to find derivative, we need to find gradient indeed. So its derivative is going to be 6x square plus 5, and for this xy we are going to use product rule now. So first function as it is derivative of second dy by dx plus second as it is derivative of 1 plus 3y square dy by dx is equal to 0. Okay, and now we need to rearrange this equation to find dy by dx. So for that, 6x square plus 5x dy by dx plus 5y plus 3y square dy by dx is equal to 0. Now we need to rearrange it. 5x plus 3y square into dy by dx is equal to minus 5y minus 6x square, and now this dy by dx is going to be minus 5y minus 6x square whole divided by 5x plus 3y square, right? Now this is your dy by dx. At which point they want us to find? It's 0 and 2. So we are going to substitute 0 and 2 now. Dy by dx is equal to x is 0 and y is 2. So it's going to be minus 5 into 2 minus 6 into 0 divided by 5 into 0 plus 3 into 2 square. This is minus 10 divided by 2 square, 4 3s are 12. So that is equal to minus 5 divided by 6. So your required gradient is equal to minus 5 divided by 6. Okay, this is your gradient, minus 5 divided by 6 in this question. Let's move to next question now. Okay, for next question we have, well, it's a pretty easy question again. 2x square. Find the gradient of the curve with this equation at the point 2, 1. So it's 2x square minus 4xy plus 3y square, right, is equal to 3. So at the point 2, 1, at 2 and 1. So let's differentiate. That makes it 4x minus 4. Again, I'm going to take xy as a product rule. I'm going to apply product rule here. So first function as it is dy by dx, that is the second function, plus second as it is derivative of first, plus it is going to be 6y dy by dx is equal to derivative of 3 is going to be 0. So this is 4x minus 4x dy by dx minus, that is 4y plus 6y dy by dx is equal to 0. And we need to find dy by dx, so it is 6y minus 4x dy by dx is equal to 4y minus 4x. We are going to take 4y and 4x on other side. At the end we have dy by dx is equal to 4y minus 4x divided by 6y minus 4x. Okay, now this is your derivative, and it is at 2, 1. So at 2 and 1 we need to find the derivative. So your derivative is going to be dy by dx is equal to 4y minus 4x divided by 6y minus 4 into x. That is equal to 4 minus 8 divided by 6 minus 8. That makes it minus 4 minus 2, that is 2. So your gradient is equal to 2 in this scenario. Is that clear? So it was a pretty simple question in which we had to find dy by dx. Point was given and we used implicit differentiation to find out dy by dx, right? Okay, now let's move to next question. Here you go. In this question, the equation of the curve is x cube minus x square y minus y cube is equal to 3, and we need to find out find dy by dx in terms of x and y, and find the equation of tangent to the curve at this to 1, giving an answer in the form of ax plus by equals to c, right? So let's start. Okay, in this question, the equation of the curve is x cube minus x square y minus y cube is equal to 3. Find dy by dx in terms of x and y. So we write x cube minus x square y minus y cube, okay, is equal to 3. So we are going to find dy by dx 3x square minus, now we apply product rule here, okay, u dot v. First function as it is derivative of second, that makes it dy by dx, okay, plus y as it is derivative of first, that makes it 2x, minus it is 3y square dy by dx is equal to 0, okay. And now again we are going to rearrange it for dy by dx. So that will be 3x square minus x square dy by dx plus 2xy minus 3y square dy by dx is equal to 0. Now what you need to do is you are going to rearrange dy by dx. So it is 3x square plus 2xy is equal to x square plus 3y square into dy by dx. So I have taken these two terms on right hand side and taken dy by dx common as well. So dy by dx now will become equals to 3x square plus 2xy divided by x square plus 3y square, right? So find dy by dx in terms of x and y. So this is my derivative. Find equation of tangent to the curve at 2, 1, giving your answer in this form. So at 2 and 1, so first of all at 2 and 1 we need to find our gradient at 2 and 1, right? So dy by dx equals to 3 into 2 square plus 2 into 2 into 1 divided by 2 square plus 3y square, right? That makes it 12 plus 4 divided by 4 plus 3, that makes it 16 divided by 7. So slope is equal to 16 divided by 7 and point is 2, 1, and we need equation of tangent for this. So now slope is equal to 16 divided by 7 and point is 2, 1, and we are asked to find out equation of tangent. So you write equation of tangent is going to be equation of tangent, it is y minus y1 is equal to m x minus x1, right? So y minus 1 is equal to 16 by 7, that is x minus x1. So y, it is 7y minus 7 is equal to 16x minus 32. So 16x minus 7y minus 32 plus 7 is equal to 0. So that is 16x minus 7y minus 25 is equal to 0. Now this was the format they wanted us to find equation of tangent. Okay, so now in my next question, okay, next question is exactly the same as we did, I guess, in the previous question. we need to find out the equation of the curve is given 3x square minus 4xy plus y square, and show that there is no point. I think we have done this question. Yes, it is. There was no point with the x and y. 45. Just a minute. Yes, we have done it. Okay. The next question is, here you go, 45. You have done this question. And yes, here's another question. The equation of the curve is 2x square plus xy cube plus y4 is equal to 10. So you need to show that dy by dx is this. So here you go. It is 2x4 plus xy cube plus y4 is equal to 10. Okay, now you differentiate it, that makes it 8x cube plus. Now we are going to apply product rule here. Okay, u dot v. First function as it is derivative of second, that makes it 3y square dy by dx plus y cube, second as it is derivative of first, and plus 4y cube dy by dx is equal to 0. So that is going to be 8x cube plus 3xy square dy by dx plus y cube plus 4y cube dy by dx is equal to 0. So it is 3xy square plus 4y cube dy by dx is equal to minus y cube minus 8x cube, and in next step it is dy by dx equals minus y cube plus 8x cube divided by 3x y square plus 4y cube. I have taken minus common from numerator, so this is 3x y square plus 4y cube. This is what is required. Okay, dy by dx. Hence show that there are 2 points on the curve at which the tangent is parallel to x-axis, and find the coordinates of these points. So if tangent is parallel to x-axis, just remember that x-axis itself is having slope 0, right? And lines with positive gradients and lines with negative gradient. So we are going to substitute minus y cube plus 8x cube divided by 3xy square plus 4y cube. Now in order to have gradient equal to 0, or the derivative parallel to x-axis, hence show that there are 2 points on the curve at which the tangent is parallel to x-axis. So for tangent to be parallel to x-axis, its gradient should be equal to 0. That makes it y cube plus 8x cube equals to 0. So this whole thing multiplied with 0, and this minus 1 also divided by 0 would be 0. So y cube is equal to minus 8x cube. That makes it y as minus 2x if we take cube root on both sides. So generally what we do in these situations, we go back and put this y equals to minus 2x in the original equation. So y equals to minus 2x in original equation. Now we put y equals to minus 2x in original equation. So 2x4 plus xy cube plus y4 is equal to 10. So here you go, 2x4 plus x minus 2x cube plus y4 equals 10. So 2x4 minus 8x4 plus y4, we are going to substitute y as minus 2x here. Y equals to minus 2x. So minus 2x4. So that is going to be 2 to the 4 to the 8 to the 16. x4 is equal to 10. So that is equal to 10x4 is equal to 10. That makes it x4 is equal to 1. Now hold on. We don't write x only equal to 1. We are going to simplify it using algebraic identity. x4 minus 1 equal to 0. That yield x square plus 1 into x square minus 1 is equal to 0. Which further yields x square minus 1 equal to 0. So x plus 1 equal to 0 and x minus 1 equal to 0. So x is equal to minus 1 and x is equal to 1. These are two possible answers. Now x is 1 and minus 1, we come back to this equation for corresponding y coordinates. So we say, okay, when x is 1 and when x is minus 1. So y is equal to minus 2x minus 2. So first point is 1 and minus 2. And the second point is y equals to minus 2x, that is 2. So that point is going to be minus 1 and 2. So these are 2 points on this given curve where tangent is parallel to x-axis, right? Okay, now if we move to next question, that's pretty easy. Find the gradient of the curve at the point with the coordinates this. So that is x cube plus 3xy square minus y cube is equal to 1. Now I want you people to stop this video and try to solve it yourself. Okay, now let's see what you have done, and here is the solution. That makes it 3x square plus 3 taken as common. We apply product rule here. First function as it is, derivative of second, 2 dy by dx plus y square as it is, derivative of first, minus 3y square dy by dx. That is equal to 0. So 3x square plus that is going to be 6xy dy by dx plus 3y square minus 3y square dy by dx is equal to 0. So we have 6xy minus 3y square bracket close dy by dx is equal to minus 3x square minus 3y square, and this is dy by dx is equal to minus 3x square minus 3y square divided by, it is 6xy minus 3y square. Now the point given where we have to find the gradient is 1 and 3. X is 1, y is 3. So x is 1, y is 3 divided by 6. X is 1, y is 3 minus 3, y is 3. That is equal to minus 3 minus 27 divided by 18 minus 27. So that is minus 30 divided by minus 9. So its 3 tens are and 3 threes are. So 3 whole 1 by 3 is your slope, or 10 by 3, right? Okay, yes. Okay, so that's all for this video. Do subscribe my channel for new stuff, and if you have any queries, you can WhatsApp me on my given number. You can contact me, and keep watching. Thank you very much. Take care.